Rules for obtaining images formed by concave mirrors. When an object is placed in front of a concave mirror, an image is formed. The image is formed at that point where at least two reflected rays intersect or appear to intersect. Rule 1. A ray of light which is parallel to the principal axis of a concave mirror passes through its focus after reflection from the mirror. Rule 2. A ray of light passing through the center of curvature of a concave mirror is reflected back along the same path. Rule 3. A ray of light passing through the focus of a concave mirror becomes parallel to the principal axis after reflection. Rule 4. A ray of light which is incident at the pole of a concave mirror is reflected back, making the same angle with the principal axis. Formation of different types of images by a concave mirror. The type of image formed by a concave mirror depends on the position of object in front of the mirror. Between the pole P and focus F, at the focus F, between focus F and center of curvature C, at the center of curvature C, beyond the center of curvature C, at far off distance called infinity. Case 1. Image formed by a concave mirror when the object is placed between pole and focus of the mirror, object between P and F. We have an object AB placed between the pole P and focus F of a concave mirror. That is, the object is within the focus of the concave mirror. To find out the position and nature of the image starting from A, we draw a ray AD parallel to the axis. This ray gets reflected at D and then passes through the focus F. A second ray of light AE passing through the center of curvature C strikes the mirror normally or perpendicularly at point E and gets reflected back along the same path. When an object is placed between the pole P and focus F of a concave mirror, the image formed is behind the mirror, virtual and erect, and larger than the object or magnified. Case 2. When the object is placed at the focus of a concave mirror, object at F, the object AB has been placed at the focus F of the concave mirror. Now the parallel ray of light AD coming from the top of the object gets reflected at D and passes through the focus F, giving us the reflected ray DX. The second ray of light AE passing through the center of curvature C is reflected back along the same path, giving us another reflected ray EY. We find that the reflected rays DX and EY are parallel to one another. These parallel rays will intersect or meet at a far off distance to form an image at infinity. And since the image is formed at infinity, it is not possible to show it in our diagram. When an object is placed at the focus of a concave mirror, the image formed is at infinity, real and inverted, and highly magnified or highly enlarged. Case 3. When the object is placed between focus and center of curvature, object between F and C. The object AB has been placed between the focus F and center of curvature C of a concave mirror. Now a ray of light AD parallel to the principal axis gets reflected at point D and then passes through the focus F. A second ray of light AE passing through the center of curvature C falls normally on the mirror surface at E and returns along the same path. When an object is placed between the focus F and center of curvature C of a concave mirror, the image formed is beyond the center of curvature, real and inverted, and larger than the object or magnified. Case 4. When the object is placed at the center of curvature of a concave mirror, object at C, the object AB has been placed at the center of curvature C of the concave mirror. A ray of light AD which is parallel to the principal axis passing through the focus F after reflection. Now the second ray of the light that we usually use is the one passing through the center of curvature C. But in this case, the object itself is placed at the center of curvature, so we cannot use this ray of light to locate the image. Here we will use rule number 3 of image formation, which says that a ray of light passing through the focus of a concave mirror becomes parallel to the principal axis after reflection. So we now take the ray AE passing through the focus F. When an object is placed at the center of curvature C of a concave mirror, the image formed is at the center of curvature C, real and inverted, same size as the object. Case 5. When the object is beyond the center of curvature of the concave mirror, object beyond C, the object AB has been placed beyond the center of curvature C of the concave mirror. A ray of light AD, which is parallel to the principal axis, passes through the focus F after reflection. A second ray of light AE passing through the center of curvature falls normally on the mirror surface at E and returns along the same path. The two reflected rays intersect at A dash. Thus, A dash is the real image of point A of the object. To get the complete image, we draw A dash B dash perpendicular to the axis. Case 6. When the object is at infinity, we have a concave mirror M. Keep the object beyond the center of curvature, that is far away, for the mirror. Since the object is very far off, it cannot be shown in the diagram. Because the object AB is very far off, the two rays AD and AP coming from its top point A are parallel to one another but at an angle to the principal axis. These parallel rays get reflected at point D and P and then intersect at point A dash in the focal plane of the mirror. When an object is at infinity from a concave mirror, the image formed is at the focus F, real and inverted, and much smaller than the object or highly diminished.